I want you to take a look at this diagram. What do you see? Get off your phones. What do you see?
A really poorly drawn red rectangle.
Okay, so there's a red rectangle. How many red sections are there?
2.
How many white sections? So if this broke up, I would have 1 white section and 2 red sections. How many white bricks would I have if I have 3 of these?
3 white bricks.
Do you agree?
Yeah.
3. How many red bricks would I have? 6. If I have 100 triple plex here, how many white bricks would I have? How many red bricks? If I have Avogadro's number of bricks, like a triplex, I have Avogadro's number, how many whites will I have?
Avogadro's number of bricks, and then
the red one, what are you going to do for that one?
times it by 2.
Times it by 2. Okay, so you've got this concept that a whole piece of something can be broken into multiple parts. That is how it works in solution. If you dissolve a solid in water, you would represent it like that, or you would represent it like this. Either way would be correct. Are you okay with that? All right. Now, if I have sodium chloride solution, sodium chloride is highly soluble. So in solution, you don't really have sodium chloride. You have sodium ions and chloride ions. So if your concentration of this is 0.2 moles per liter, what will be the concentration of sodium ions? We just did an analogy on the board. So take a wild guess. Matthew? 0.20 moles per liter. For every 1 sodium chloride that gets split apart, you make 1 sodium ion. So therefore, there's the same number of sodium ions as there are sodium chloride. I can say 0.2 moles of sodium chloride per liter times 1 mole of sodium ions for every 1 mole sodium chloride. This is a formal way to show your work. This is a good way to show your work. So basically, you do it the same way that we did the triplex of blocks. You multiply the initial concentration by how many of those ions you produce. So if I have calcium chloride at 0.5 moles per liter, what will be my concentration of calcium ions, and what would be my concentration of chloride ions? Allie? Which one's one?
Wait, like, because when we do 0.5 multiplied by 2.
For which one? Chloride?
Alright.
Yeah. So that would be 1 mole per liter. What would the calcium be? 0.5. There's only one of them. So 0.5 mole per liter calcium chloride times 1 calcium for every 1 calcium chloride. So you're left with moles of calcium per liter. See how you do that? This is what I want you to start doing. All right, so let's take a look at your note from yesterday. Mole ratios here. For the dissociation, this is a chemical reaction showing the dissociation of an ionic compound. Ionic compounds dissociate because they are ions held together by an attractive force, positive for negative, electrostatic force of attraction. All right. It wants the dissociation for aluminum nitrate. This is a dissociation equation when you take your solution, your ionic compound, and on the right-hand side you put its ions. You really have to be careful that you put the charge for the ions on the right-hand side. Chloride will always be Cl minus. Doesn't matter how many are in the formula. If your formula like CaCl2, you don't put Cl2 negative. It's 2 Cl negatives. All right, so it was 0.10 mole per liter. So how much aluminum, how much nitrate? Yeah. Awesome.